All right, in this video, I want to simplify these radical expressions over here, or I guess these radical values. And to do that, I just have to rationalize the insides of the radicals. So for the first one, I'm going to multiply the top and bottom by 2 plus root 3. Oops, no square root there. Bracket. And for the second one, I'm going to multiply the top and bottom by 2 minus root 3. So let's expand now. We're expanding with FOIL basically on the top and the bottom. So 2 times 2, or 2 root 3 plus 2 root 3 plus 3. And then on the bottom, 2 minus, I guess I'll do the plus first. Oh, now let me simplify this. I guess I could do this expansion here as well. 4 So if I combine like terms in the top over there, I'll get 7 plus 4 root 3. And if I combine like terms in the bottom, I'll get 4 minus 3. These two cancel, just a 1. Then same idea here. I'll get in the top 7 minus 4 root 3 over 1. These two will cancel. So I have root of 7 plus 4 root 3 plus the root of 7 minus 4 root 3. Now you may be wondering how to combine these, and there's a step to actually combine these, but the easier way to actually combine it would be to look back at the original question and figure out that it would have been best to actually not expand in this step here. So instead of expanding the top in these, imagine if I just wrote the top in factored form. So instead of the top being written in expanded form, I just wrote the top as 2 plus root 3 squared. And this one would be 2 minus root 3 squared. Because this is like extremely hard to combine. You have to refactor it again, but that'll just give you this over here, which means that it was just best to not expand the top over there. Now the squares and square roots just cancel. So you're just left with 2 plus root 3 plus 2 minus root 3. Root 3 cancel. So my final answer is just 2 plus 2, which is 4. So the trick in this kind of question here compared to usual rationalizing questions is you don't expand the top so that this square and square root will eventually cancel out. Let's take a look at the second example in this video for practice. This one I think is slightly more difficult. because the numbers are no longer the same now, and we can't really use that trick of squares over there like we did in this one. We're probably going to have to end up factoring it. And if you want, I can show you how to factor this one as well. We could have just, well, this one's a bit hard to factor too. So I won't really show it over here, but I'll show it in this example over here probably. I will end up having to factor if something like that happens at the end because top and bottom is not the same in this one. So let's start by rationalizing this one. Multiply the top and bottom by 17 plus 12 root 2. And over here, multiply the top and bottom by 17 minus 12 root 2. So for the top here, I will get 51 plus 36 root 2 minus 34 root 2 minus 24 times 2. I think I did that right. Bottom, I'm just going to do it a bit quicker. I'm going to ignore the middle terms because I know they'll cancel out. So I'll get 289 minus 144 times 2. Here, this is going to be pretty similar. Bottom is going to be the same. Top 51 minus 36 root 2 plus 34 root 2 minus 24 times 2. Bottom is basically the same, 289 minus 144 times 2. Can simplify these. Fifty-one minus 24 times 2. 24 times 2 is 48. 51 minus 48 is just 3. 3 plus 2 root 2 on the top. Bottom is just 289 minus 288, which is 1. Here on the top, again, I have 3 minus 2 root 2. Bottom, I have 1. I can just simplify this to square root of 3 plus 2 root 2 minus root of 3 minus 2 root 2. Now we want to combine these two square roots over here, but there's no really simple way to do it. What we can do is we can factor and try to turn these into perfect squares over here. So I want to figure out a perfect square that can turn into this. So I need a constant and I need a root term. So I'm going to basically do it by trial and error. So we know that the root term has to be square root of 2. It could have a coefficient potentially, but because this is 2 root 2, it's very likely that when I expand it out, so when I do root 2 times something, it's going to give me 2 root 2. So if I have root 2 plus something squared, I need to figure out this constant here and this constant here. To get 2 root 2, I just need to do root 2 plus root 2, which means that this should be a 1 over here, because then when I expand it out, Root 2 times root 2 is just 2. Root 2 times 1 is root 2. 1 times root 2 is root 2. And the addition of these two will give me 2 root 2. So then I just have to test with the constants. 1 times 1 is 1. And then 2 plus 1 is just 3. So 3 plus root 2. This gives me the exact same thing as that over there, which means I can replace this with root 2 plus 1 squared. And this one, it would be the exact same expansion, except instead of plus, it would be a minus, I believe, but let me double check it. So root 2 minus 1 times root 2 minus 1. Root 2 times root 2 is 2 minus root 2 minus root 2 plus 1. 2 plus 1 is 3, so 3 minus 2 root 2, which does match that bracket over there. So I'm going to replace this with root 2 minus 1 squared. Now the squares and square roots can just cancel. Root 2 plus 1 minus, root 2 minus 1. Distribute this negative into the bracket. Then finally combine like terms. The final answer for this question is 1 plus 1, which is 2. And this factoring step right here at the end, it's a pretty tricky step. It's only expected in really hard or challenging questions like this. And some of the key hints I'll give you with these factoring questions is make sure you put the bigger numbers at the start of each perfect squared bracket. For example, root 2 is larger than 1. So that's why you want to put root 2 first. Generally speaking, you want to put the larger numbers first. Otherwise, sometimes you may get the negative solution, which will give you the incorrect answer in the question. So that's something to keep in mind. Because we're working with perfect squares here, put the larger number in front. Root 2 is slightly larger than 1, so always put a larger number in the front, especially for the bracket with a negative sign. If you made it to the end of this video and you found this content helpful, please hit that like and subscribe button. Thank you for watching and have a wonderful day.